Okay, when we're graphing angles on a coordinate plane, we always start our 0 degrees or even 0 radians is always going to be on our x-axis. So our angles will always start with their initial side on the x-axis. From there, 90-degree angles are straight up. We know it'll be 90 degrees. A straight line is 180 degrees. 3/4 of the way is 270. Come back for our next 360 degrees. So to graph this angle, 170 is, we start by going counterclockwise, going up because it's positive. 170 is a little bit short of 180 degrees. So our angle would end in the second quadrant, just a little bit short of 180. When we have negative angles, just means instead of starting by going up, we're going to start by going down. So that's what the negative angle does to it. So in this case, essentially 0 degrees is in the same place. Our negative 90 is where 270 was. Negative 180 is in the same spot as a positive 180. Negative 270 up top. And negative 360 would be a full circle. So for negative 290, we would start by going down. So we'll be a little bit beyond the 270 mark. And that angle would end in the first quadrant. For 580 degrees. This one's positive, so it's going to start by going up. However, we know, 180, that 580 is going to be more than 360. So one full rotation isn't enough. Now we just need to find where it stops. 360 plus another 90 would be 450. Another 90 beyond that would be 540. Another 90 beyond that would be 630. We could keep going for days, but at this point we know 580 is between 540 and 630, so we know it would stop in the third quadrant. Okay, one important term you're going to be hearing a lot throughout the trig unit is a reference angle. So reference angle is the acute angle. By acute angle, that means it's going to be between 0 and 90 degrees made with the x-axis, and that x-axis is key when an angle is graphed in standard position. So, for example, the first angle we graphed on the previous slide was 170 degrees. So we have this 170 degrees in quadrant 2. Its reference angle is this angle right here, the one from the angle down to the x-axis. So again, always the angle to the x-axis. And in this case, we know a full all the way to the x-axis is 180 degrees. We stopped at 170 when we graphed that angle. So that would mean its reference angle is the difference between 170 and 180, which would be 10 degrees. Essentially, a reference angle takes all the infinite amount of angles out there, and it lets us refer to it as an angle between 0 and 90, so it makes problems a lot more doable. For this next one, for negative 290, so we graphed this one around, we had 270, we went 20 degrees past that. However, the reference angle, again, I can't say this enough, is the one made with the x-axis. So it's this piece that we didn't graph. Well, to find this, we know a full circle is 360 degrees. We want to know how much short we stopped that full circle. So we have 360 minus 290. And we find out that this reference angle is 70 degrees. For the last one, that was the angle of 580 degrees. So our reference angle, again, the angle made with the x-axis. It doesn't matter how many times we went around in circles before we graphed it. We care about this acute angle right here. So we ran around once for 180, but then we went around again, and that measure was 540. Oops, it looks like I have this marked wrong. That should say 540. This one up here should say 450, like what we just did on the previous slide. Anyways, we need to know how much further past that 540 that we went. So if we just do 580 minus 540, we get that that reference angle is 40 degrees. Instead of trying to memorize what to add and subtract, just visualize we're going 580, that is 40 degrees past 540. So since when we graph angles, sometimes we're going around in a circle multiple times. That means different angles can end in the same spot. So coterminal angles or angles that have the same terminal side. So all that's saying is that we could take all the infinite angles out there and really just refer to them as an angle between 0 and 360, because after 360 they're going to start repeating again. So for example, with negative 290, on the previous side we saw it had a reference angle of 70. So instead of thinking about this angle going backwards as a negative, a coterminal angle could be the angle that takes you to that exact same spot, but going in the positive direction. In that case, we already knew that reference angle was 70. Well, it's in the first quadrant, so a positive coterminal angle for that would just be 70 degrees. For 580, we went around twice to get to that 580 spot. So we know this was a reference angle of 40. Again, we just found that. Instead of thinking that it was 40 past that 540 degrees, let's reduce this down to just one time around, and we could have 40 past 180 degrees. Well, 180 plus 40 would be 220 degrees. So that would be a coterminal angle. Now that's visually what it means. Algebraically, a coterminal angle, if you just add or subtract 360 degrees from your angle measure, that'll give you all the coterminal angles, because 360 degrees is a full circle. So for example, for this one we had originally gone 580 degrees. If I just subtract 360, notice minus 360, that equals 220 degrees. For the negative 290 over here, notice if you add 360, that equals 70 degrees. So for coterminal angles, you just keep adding or subtracting 360, and you will get multiple coterminal angles. Okay, so degrees you guys have been working with for a long time. Radians are what you guys added last year. So radians are now what we're going to be using way more often as we get into trig. So a radian measure, keep in mind the circumference of a circle, you always use 2 pi. That's because all the way around is a measure of 2 pi. So a 2 pi is a full circle, aka 360 degrees. Now with radians, when we're graphing, we're going to use fractions a lot to kind of help us out. If 2 pi is a full circle, well, that means half a circle is pi. So pi is equal to 180 degrees. If you cut that in half, because this is cut into an even fourths, that means 90 degrees is pi over 2. And if each one is a pi over 2, we have 1 pi over 2, 2 pi over 2, 270 degrees would be 3 pi over 2. So now we want to get used to graphing in radians and being able to think in radians. We don't always want to convert back to degrees. So good way to do that, first example we will do is a unit circle value that you guys should have been used to seeing. We're going to graph 5 pi over 3. So right now, just looking at that, you might not have any idea where that goes unless you remember that unit circle. Here's where we want to think about these in fractions. So we know we start at 0, so our starting side, I'll change colors, will be here at 0, so that's 0 radians. Well, if we're thinking in thirds, over here, a full pi, and here's where we want to use fractions, that's the same as saying 3 pi over 3, because we're trying to figure out where 5/3 goes. Well, a full pi is 3 over 3. We know 2 pi. Okay, let's change this to a fraction. That's the same as saying 6 pi over 3. So if you think about dividing this half up into thirds, this third down here would be 4 pi over 3. This third over here would be 5 pi over 3. So 5 pi over 3 graphs to the fourth quadrant, just a little bit into the fourth. And if you remember from last year, just to kind of help you visually right now, 5 pi over 3 is the same as 300 degrees. But we want to be able to where we can graph these without thinking about the degree measure. So let's do a couple more together on the next slide. Okay, so we're going to look at graphing 3 pi over 4 and 15 pi over 4. So if we want to graph in fourths, that means we want to change our values on these axes to be fourths. So obviously 0 is going to stay 0. That would be the same as saying 0 pi over 4. If you have up here pi over 2, I think that is the fraction 1/2. Well, to convert 1/2 into fourths, multiply top and bottom by 2, that's 2/4. So instead of thinking this as pi over 2, let's think of this as 2 pi over 4. For a full pi, well, there are 4/4 in a whole. So that's the same as saying 4 pi over 4. I think it's going to move the same every fourth quadrant each time. So if we have 0 pi over 4, 2 pi, 4 pi, down here would be 6 pi over 4. A full circle, instead of 2 pi, we can think of that as 8 pi over 4. So again, we're just switching the fractions to have a different denominator, the same denominator as the angle we're graphing. So if we want to graph 3 pi over 4, well, 3 is going to be halfway from 2 to 4, so that would graph to exactly halfway in the second quadrant. For 5 pi over 4, or for 15 pi over 4, we're just going to keep going around the circles. I think we had 2 pi, 4 pi, 6 pi, 8 pi. Now we need to keep going. So another half would be 10 pi. Another half would be 12 pi. Another half would be 14 pi. And 14, 1/4 further, that would graph exactly halfway into the fourth quadrant. So again, if you can think, a full circle is 2 pi around. 2 full circles, that means would be 4 pi around. Again, we're just switching into fourths. Think about 4 pi in fourths. That would be 16 pi over 4. So it makes sense that 15 pi over 4 would fall just 1/4 short. Okay, let's do a couple more just so you can see this thought process. This time we'll deal with fifths. So we're graphing 9 pi over 5. Again, we start at 0. And here's where we don't have a good spot for the 90, so we're just going to think in halves for now. We know a half circle is pi. Well, in fifths, that means a half circle is 5 pi over 5. So every half circle we do, that's going to be a 5 pi over 5. If you go another half circle, 5 plus 5, that makes 10 pi over 5. Remember, a full circle should be 2 pi. So it should make sense that 5 times 2 is 10, 10 pi over 5. So to graph this 9 pi over 5, 9 is 1/5 short of 10. So it's going to come around and be 1/5 short of your full circle. For negative 14 pi over 5. Same idea, and the negative means the same thing as it did with degrees. We're just going to start by going backwards. So I think negative, we would have negative 5 pi over 5, negative 10 pi over 5. Another half circle would be negative 15 pi over 5. We want 14, so we're going to stop 1 short. So to graph in radians, just think you always want to change your quadrants to match the denominator that you're graphing in. Okay, reference and coterminal angles are the same thing in radians, just using different values. So first we'll look at the 15 pi over 4 that we did on the previous slide. If we're looking for its reference angle, it's still that acute angle to the x-axis. So again, this is where those quadrant labels really help. We graphed 15 pi over 4. It was just 1 pi over 4 short of 16 pi over 4, so therefore its reference angle is pi over 4. As far as a coterminal angle, this one went around all the way twice. If we think about what the angle would have been if it had just gone once, well, we already know the reference angle is pi over 4, so this time instead of dealing with 16 pi over 4, let's look at 8 pi over 4. 1 pi over 4 short of that, I think 8 minus 1 is 7. So a coterminal here would just be 7 pi over 4, because that's what it would be if we went around once. Now, I know you don't always want to think visually with the coterminals. So I think for degrees, we add and subtracted 360 to find coterminal angles. So for radians, we're going to add and subtract 2 pi to find coterminal angles. So just so you can visualize that, we would have done 15 pi over 4 minus 2 pi. Now we're dealing with fractions here, and as we know, in order to add or subtract fractions, we need a common denominator. So this would be the same as saying 2 pi over 1 times 4 on the bottom, times 4 on the top. We have 15 pi over 4 minus 8 pi over 4. Now we can subtract straight across. 15 minus 8 is 7. So that gave us our coterminal angle of 7 pi over 4.